Okay, perfect. So I will start, and if someone from their sound says no, of course I will stop, but let's get started. Perfect. So extend your Kubernetes with open source or with the power of open source. Very, very good. Great that you have all selected to be here on Friday to learn more about Kubernetes and cloud native. How exciting. I'm very happy. Okay, let's get started. So what value do you get by attending this talk? You're going to get to learn hopefully new things. I hope that's the goal here. This is going to be a session where I will be running through essentially a lot of different projects, hopefully getting you inspired to try out some of the things yourself, as well as for you to get an understanding how to kind of, add on things to your Kubernetes so that you can get the most out of the open source ecosystem around it. So that's the value that I'm looking for everyone to get from here mostly. So who am I and why am I blabbering on here about? So I'm Annie, I'm CMO at Vision, which is essentially a DevOps as a service company where we provide help if you're looking to, start your cloud native or Kubernetes journey in forms of products and services. But other than that, I'm also a CNCF ambassador as well as an Azure MVP. And what that does mean, that means that I just love everything cloud native, or I'm passionate about it, and Kubernetes, and I love talking about it in events such as this, or in general sharing about it with people. So I'm also a Kubernetes and CNCF meetup co-organizer since 2017 already, so a few years. For Finland, so I'm from Finland originally, it's quite close by to Denmark as well. But I live in Zurich nowadays for since about 2 years. So I also coach early stage startups, and I am co-host of the Cloud Gossip podcast that you can find from that address. And also I've been hosting, or been one of the hosts for Cloud Native Live, a weekly live stream by CNCF since 2021, I think. So every Wednesday you have might have seen me in the CNCF page there talking about things as well. I also have been a track chair in KubeCon previously, both in North America as well as Europe. So there's a lot of fun there as well. But yeah, then let's get to the agenda a bit closer. Soon I will explain this emojicon, but not right now yet, the icon there. But first, we are in the introduction portion of this talk, so we're doing well, already on making good headway here. And then after this, I'm gonna say a few considerations, because the reality is that even if we would all like to use all of the projects that I talk about, that might not be the best case scenario, even though I hope that you get inspired and try them out. But a few things to consider before jumping into the deep end, essentially. Then I have a few bits about open source, like why do I actually have the open source in the title of the session? Why am I focusing on open source tooling that you can use? And then we have the projects as well. I'm not going to reveal which ones they are right now, but I do have a bit of a mix towards like more mature and more newer projects. But mostly today we're going to be focused on the more mature projects that you might have already heard about or not. I don't know. But since this is kind of very like things that you can already do as of today, not the latest and the greatest necessarily. But so that's the kind of scope that we're working on today. And then we have a wrap up with all the resources there as well. So that's at the end, and then we're gonna all see all the great stuff where you can kind of dive deeper in to learn more about the things that I'm speaking about. So let's get started. Just to gauge everyone's kind of where they are at your journey. Do you know the Cloud Native Computing Foundation beforehand? Is that familiar? Yes, a lot of nodding heads here. Yeah, good. Yeah, but not a lot in the back. That's fine. So Cloud Native Computing Foundation, aka CNCF, it's a home of Kubernetes as well as a host of other open source cloud native projects. And it hosts critical components of the global technology infrastructure. That's what it means essentially. And the mission is to build sustainable ecosystems for cloud native software. It's part of the Linux Foundation, so there's a lot of big players behind it as well. And it, for example, organizes KubeCon. Now, if we want to look at the cloud native landscape, which is essentially all of the projects or all of the different initiatives within CNCF, this is how it looks like. And if you're seeing this for the first time, it is quite a lot. It's impossible. Like you can't kind of really even see anymore all the little details. But what I always recommend that you can always kind of zoom in and start, for example, if you're looking into what should you do as far as security, there's a portion there for security, so you can zoom in there and discover more. But that is also why this session exists. So then we're going to kind of look at few projects a bit closer from this massive landscape. And actually this time it is looking quite big, so you can actually probably maybe even tell the tiles apart. I can't from my small screen here. Projects within the CNCF are divided to 3 different buckets, so to say, categories. So you have the sandbox projects, which are the very early on projects. So they might have less maintainers, less users, but they might be super promising and they might be something to look into and start using for sure. But then after you move to the incubating and the graduated phase particularly, that's when you get really mature. You have good list of maintainers, good list of contributions as well as and so forth. So it's like you become mature, and then you can even more easily, without extra additional checks, be recommended for full production, for example. And as I said, a lot of the projects today are going to be either in the graduated or incubating bracket, and I have a few sandbox projects as well. But if you're like super deep into cloud native, you've probably heard at least a lot of the projects that I'm covering today. Okay, so here is our hero. So I think to get you the context of why am I speaking about all the projects here today, or like Kubernetes add-ons to begin with. So you can imagine that this is like your typical action hero or fantasy hero. There they are, and obviously they are there alone, and they are really good, and they're probably powerful, and they can do stuff on their own, as is Kubernetes as well. But I don't think just one action hero is enough. You really do need to kind of add more stuff as well. So you usually need, other classes, other things that are specialized in the different areas. So you might need a rogue or a mage or a fighter or so forth. So there's a lot of different skill sets that you need when you are doing adventuring in the fantasy world, for example. So why wouldn't that be the case in the tech world? Why wouldn't that be the case in the case of Kubernetes? So if we then think about it, in the way that, okay, that would be Kubernetes, then we must add on some of the other things, such as, for example, service mesh, databases, security, observability policies, package management, CI/CD, and so forth, to actually bring us into a holistic and really good offering as far as things go, and building our own deployment platform and so forth. So that's kind of the theme for today. Which ones should you maybe consider adding to your roster in a way, and so forth. But before we dive there, I think everyone's familiar with this. It depends, not always the answer, but that is also very much true. So we have to consider things that I can hear. I can talk about different projects, and I can mention things, and I can say, okay, this is something that you can try out, but you do have to kind of do then the legwork on figuring out, is this the right fit for me? Because your process is the best, or obviously you can get external opinions and help as well. And some of the things to kind of consider there is think about what sort of is the ideal platform, or because now there's platform engineering, so the platform that your developers, for example, use to develop and then so forth. So think about the ideal platform, think about the ideal setup that you have, and really consider who needs to use it, what are the practices, tooling, operations, and standardization around it, what observability, what flexibility policy, and so forth. What are all the different building blocks that you need? Design then it. Honestly, you've now thought about what is the ideal configuration. Then you need to kind of start building it. And for example, it's always good to remember to have sign responsibility and create a team around this topic, for example, because even if there isn't a team, it's probably just going to be someone. If it's completely shared responsibility, it's no one's shared responsibility, and so forth. And then design the development process as well, and consider all the different variations that you have within your ecosystem, and then find the right Kubernetes features and add-ons. And this is the point where I think particularly today's session might help you get some inspiration on what could be some of the things that you can consider. And there's a lot to offer from CNCF as well. Now, if you want the deeper dive into this area, so the considerations, or how to kind of nowadays approach building your own Kubernetes features in the platform and so forth, there's a really good session by Brendan Burns that I'm going to give you the link in the end as well. So that is like an hour just on these topics. So if you really want some help there, that's a really good resource. Why then open source? Well, I think traditionally there's a few reasons why open source is considered good. And they are usually, people say the cost, because it might be more cost efficient to use it, but obviously also if you want to do open source properly, you might also want to tap into the enterprise versions of the open source and so forth. Community is a big one that people usually mention. Customizability as well. Open source tends to be, provides access to the open source code, so then you can enable customization better there. Transparency and security is usually highly valued in open source projects. And then innovation and rapid evolution is a great point as well to tap into the power of open source. But now from my side, what are my favorites from this to consider, as well as like particularly in the context of Kubernetes? I think the community and the innovation and rapid evolution are the main points. Why I kind of usually talk about open source add-ons for Kubernetes. Because, well, the reason why Kubernetes has become so big is, for example, due to the community, exactly. Because there's a lot of people building add-ons, there's a lot of people providing documentation, help, resources, and so forth. So tapping into that huge brain power where everyone collectively has worked on something, I think it's very big. And that actually then, in my opinion, and according to studies, leads to the innovation and the evolution of the technology faster as well. So that's never a bad thing in my opinion. Okay, and then if you're considering where to start your Kubernetes journey, where to kind of kick off, CNCF has this resource called the Cloud Native Trail Map. You can see it here in its full picture here, and if we zoom in a bit, we can see a bit closer, for example. So it starts from containerization to CI/CD and so forth. And actually today in this session, we're gonna be following this trail map along with our hero. So we can add the hero there. They're going to start in the containerization phase. We're not going to focus on here too much, because if you can read the text, it's essentially there. It says, Docker, use containers, so forth. So we'll probably understand that Docker is a container software, and you can use that. Then orchestrate this with Kubernetes. And then if we move to the first one, so there's a bit of teaser what will be the first one. We move there, we can see that Argo is the first one that we will be talking about today. Who here is familiar with Argo to an extent at least? Okay, a lot of hands. Okay, if this is, everyone super deep in cloud native, then you might not hear too much new about Argo here, but hopefully you will learn something new. So Argo is a set of essentially tooling that they say themselves that get work done with Kubernetes is the key there. So Argo has a lot of different points, and there's a few different software that's like different projects. For example, Fox is quite often coded as a relatively similar one, but there are differences in their scope and in their focus as well. So what is Argo then more closely? Argo is, for example, they have Argo Workflows, which is container native workflow engine. So it is an open source container native workflow engine for orchestrating parallel jobs on Kubernetes, and you can define workflows where each step in the workflow is a container, and model multi-step workflows as a sequence of tasks to or capture the dependencies between tasks as well. You can run compute-intensive jobs for machine learning or for data processing and so forth, or run CI/CD pipelines natively on Kubernetes without configuring complex software development products. And then we have Argo CD as well. So it's a declarative GitOps continuous delivery tool for Kubernetes then. And it provides a lot of good benefits from, as is all GitOps delivery platforms do. Then you have Argo rollouts as well, which is a Kubernetes controller and set of CRDs, which provide deployment capabilities such as blue-green, canary, and canary analysis and experiments, and so forth. So there's a lot of good ones, and using these already would be considered best practice itself. And then there is Argo Events, which is an event-based dependency manager for Kubernetes, which helps you define multiple dependencies from a variety of event sources. And you can manage dependencies from all of those sources and so forth. Okay, that was Argo. Moving on back to our map, and then we can see that we have two options to cover from the next one, and we can see where we end up there. and we're going to cover Helm. And Helm is very well known usually as well, so I would imagine that when I now ask who is familiar with Helm, a lot of hands would rise. Yes, a lot of hands, definitely. Another graduated project. So we have the which is package manager for Kubernetes. So it is package management is tooling that enables someone who has knowledge of an application and a platform to package up an application so that someone else who has neither of these, that they can use it, they can get the most out of it. So that is the power of package management. So Helm itself helps you manage complexity because charts describe even the most complex apps, provide repeatable application installation, and serve as a single point of authority. It has easy updates as well, so you can take the pain out of updates with in-place upgrades and custom hooks. It has simple sharing as well, so you can really easily version, share, and host on public or private servers. And then you can use rollback to an older version of a release, and you use it with charts as well then. And I think with all of these projects as well, I can also give you some kind of tips on when to use them or not, but I think Helm is very well known and very well utilized, so there's usually not that many cases where you wouldn't use Helm at all, for example. With all of these Kubernetes tooling, because Kubernetes itself is quite complex, if you have something super simple, or you just want to just do something very easily, then it might also make sense not to do some stuff. So here we are back in our cloud native trail map, and then we're gonna move on to the next one. We have 4 options next, so then we move there to Prometheus, and which is another very well known project. So if everyone knew Helm, I think Prometheus, who's familiar with that. Okay, everyone again. Well, not everyone though. So which is powering your metrics, another thing. So Prometheus is a monitoring and alerting toolkit. It collects, stores time series data from various sources, allowing you to monitor your performance, availability, and health of your applications and infrastructure. And then quite a lot of people were familiar with it, but it does provide powerful monitoring and alerting. So, and as well as scalability and high performance, as well as flexible data model and instrumentation. So you can use the flexible data model that comes with it, as well as rich ecosystem and integrations. This also comes with the territory of open source as well. So it really helps there as well, because you have all the integrations and the flexibility that I mentioned in the beginning, which is the open source and active community there. And in general, Prometheus works really well for recording any purely numeric time series, so it fits really well for machine-centric monitoring, as well as monitoring highly dynamic service-oriented architectures as well. Yeah. Then back into the trail map there, we're going to move, and then we're going to see where we end up next. We're going to end up in Linkerd. And again, who is familiar with Linkerd? Okay, there's less hands this time. Well, that's cool. Linkerd is then a service mesh. So if you have heard of Istio, for example, Istio is a service mesh as well. But Linkerd has a bit of a different approach than Istio. So whereas Istio, Linkerd has a bit of a leaner and meaner, I think, approach as well. So it's a bit more ultra light, ultra fast, and security first kind of mindset compared to Istio, but obviously there's also dependencies. It is very community minded. It's been part of CNCF from the beginning, so it has gone through all the CNCF stages. Istio is nowadays as well part of CNCF, but they joined quite recently. And the overall goal of having any service mesh or Linkerd as well is to reduce the mental head of having a service mesh to begin with, which then goes to this ultralight mentality compared to Istio, for example. So it provides observability, service level important metrics such as success rates, latencies, and reliability, and retries and timeouts, as well as security. So it has the thriving open source community that is supporting there. It has a simple minimalist design, so no complex APIs or configuration needed. For most applications, Linkerd will just work out of the box. It provides deep runtime diagnostics, so you can get a lot of comprehensive suite of diagnostic tools, including automatic service dependency maps and live traffic samples. as I said, ultra light and ultra fast. So Linkerd is built in Rust, and Linkerd's data plane proxies are incredibly small and very fast. It installs in seconds, going again into this very light mindset, as well as then actionable service metrics as well. And now usually sometimes people ask me, okay, should they use which one of the service meshes? And unfortunately the answer is always it depends on what exact feature set do you need. And there's other options as well as far as the CNCF, for example, goes. So there's Kuma and whatnot that you can think about. And then if you are running into the situation where you do need to manage multiple service meshes, I can actually give you a tip into looking into Meshery, and obviously it may be not ideal to have multiple different service meshes in your cluster, but if that just so needs to be your situation, Meshery is then a management plane for the service meshes itself. So if you run into that situation, that's a good one to look into. Then let's move on. So we're going to go to networking policy and security, and then we're going to go talk about Falco there. I know I'm asking a lot of hand raising here, but let's try it at least one more time here. Who's familiar with Falco? Okay, less hands. That's what I was expecting, because now we're getting to the projects that not everyone knows. Good. So we have Falco, which is the cloud native runtime security project, which is the de facto Kubernetes threat detection engine. So it is an incubating phase project. So that's where you can start telling, okay, if it's a graduated phase project, a lot of hands rise up, where a lot of people know it, but Falco is a bit newer as well. So it's an open source runtime security tool. So it uses calls to secure and monitor your system by parsing the Linux system calls from the kernel at runtime, asserting the stream against a powerful rules engine, and as well as alerting when rule is violated. So then it does a lot of things. So it uses ships with the default set of rules that you can check the kernel for unusual behavior, such as privilege escalation or using privilege containers, namespace changes, as well as ownership and mode changes, executing shell binaries, executing SSH binaries, as well as those kind of things. And in general, you can say Falco is composed of 3 main components. So there's the user space program, the CLI tool that you can use to interact with Falco. And then configuration defines how Falco is run and what rules to assert and how to perform the alerts, as well as the driver, that is a software that then adheres to what the Falco driver specification and sends a stream of system call information there. So these are all the components of Falco, and Falco has seen, as far as I can see, like a really good growth recently, and it is starting to be, well, not starting to be necessarily, is already being adapted by quite large enterprises and organizations. So even though it's a bit newer than some of the other projects there, I do highly recommend kind of looking into it, as well as thinking, is this the right tool for you in this context? Okay, and then we go back to our cloud native trail map, and then we can click to see, okay, where do we go next? We are moving on, and we're going to VThis. Which is the next project here, another graduated one. But how many is familiar with VThis in general? Okay, 1 hand, 2 hands. Oh yes, you're getting a bit shy with the hands, but that's good, that's fine. So that is a long time graduated project, but a bit less known clearly then. So it is, on their own words, scalable, reliable, MySQL competitive, cloud native database. So it's a MySQL specifically focused. So it's a database clustering system designed to provide horizontal scalability and manage large-scale and MySQL workloads. It was initially developed by YouTube, but it is nowadays part of CNCF, as is most of the projects or tools that I'm talking about today. So it's really well suited for applications that require high availability, efficient sharding, and scaling without sacrificing then kind of the familiar tooling of MySQL or interface. So it provides a lot of different things, such as horizontal scalability. So it can handle increased loads without major changes to the underlying database schema or application code. And then it shards the data across multiple instances, enabling then efficient scaling from there. It does this, the automated sharding and resharding as well. So it automates the process of sharding and resharding these. So it really works helpfully there. It is SQL compatible as well. which is a big part of it. And if you are not needing an SQL compatibility, then likely not the best choice for you. It has high availability and failover, as a lot of these Kubernetes projects do. It has cloud native and dynamic environment. So as always, it's really great to use tooling that really complements your Kubernetes setup. So actually, like, as far as considerations go, it is important to choose obviously tools that fit to your processes. It is better to actually choose tooling that fits to your need, not make your needs fit the tooling's need in a way, if you think about that. And that is a good example of it. And it has database operations simplification as well. So it simplifies the database operations by managing complex tasks like connection pooling, load balancing, and schema changes as well. Back to the trail map we go. So we have, I think, 3 projects here in the streaming and messaging that we can go into. Now you can, I guess, take bets on where does it go in your mind. We go there. Oh, it did a loop. It did a surprise there. We are talking about GRPC now. Who is familiar with that? Okay, more hands, because again, graduated project. I can see the correlation there. So it's a high performance open source universal RPC framework there. Then it has really efficient communication. So it has efficient and multiplexed communication, reducing latency and optimizing data transmission between services, language agnostic APIs, and bidirectional streaming. So gRPC supports bidirectional streaming, enabling real-time communication and interaction between the services as well. And since a lot of people were familiar with it, you don't have to dive too deep into there in general. But I think in general with all of these tooling, and with this one, for example, when to use it if you're using a microservices architecture, if you have multiple languages, a polyglot environment, then you need efficiency and performance are, for example, cases to use this. Okay, moving back to the trail map. And then we have 3 options to choose from here. And then we're actually going to go there, and we're going to go to another graduated project. If I had known that everyone was really deep into cloud native, I could have maybe selected some other projects, but no worries. Who's familiar with Container D then on the other hand? Okay, less hands than the previous one, but still. So it's an open source container runtime that provides core functionalities for running containers in a containerized platform. So it is essential container operations such as image management, container execution, and container lifecycle management as well. It is lightweight and very focused, so it's designed to be lightweight and modular, emphasis on the modular container runtime, and focusing on core container operations. So its simplicity and streamlined design make it efficient for running containers without unnecessary overhead. It provides standardization and interoperability as well. So it's designed to be compatible with various container runtimes and orchestration platforms. So it is standard interfaces and APIs enable seamless integration with tools like Kubernetes, allowing for consistent container management across different environments as well. It has customizable and extensibility, which usually all of these projects quite often have, because as I said, that is one of the major points why open source and Kubernetes work really nicely as well. Back to the trail map, and we're going to move on to software distribution. And I know that you're seeing that we're getting to the end of the trail map, but don't worry, I have a few extra projects outside of the trail map as well. So don't worry, the fun isn't over yet. So we have software distribution, and we're going to talk about the update framework. How many is familiar with that? Ah, that's surprising. That is fun, though. It was even a graduated project. But yeah, it's a framework for securing software update systems on the other hand. So it ensures that the integrity and the security of software update processes. So it provides a set of best practices and tools for securely distributing and updating software across these various platforms. So it employs cryptographic signatures and metadata to verify the authenticity of the updates, protecting against tampering, malware injections, and other threats. And by offering these robust methods of securing the software updates, it enhances the trustworthiness of software distribution systems in general and helps safeguard users then, again, potential vulnerabilities. that comes from these compromised updates. So it has the software supply chain security helps. So it provides, for example, help with including man-in-the-middle attacks, tampering, and supply chain compromises. It ensures that only trusted updates are installed on the user systems. It has multi-layered security, so it helps, it uses techniques such as signing, role-based access control, or metadata verification. It has flexibility and compatibility. Again, a big point in all of these projects that you can start telling, okay, these are good parts about all the open source and Kubernetes and CNCF ecosystem. So we have, if you're thinking about when to use it, is if you use it maybe when you have a distributed software that needs to be securely updated across various endpoints and services, or if your software is super critical. So if your components are very critical, and especially those that handle sensitive data or play a crucial role in system operation, as well if you have open source projects that you need to plug into, or if your environment is very high risk. And now if you think about why should I not use it, or in what kind of cases shouldn't I use it, you shouldn't probably use it for if the software is super simple or non-critical, again, not maybe the best, or for small scale projects, or if you have really good existing security measures already, then it might not be necessary, or for short-lived systems, or if you need to tap into legacy projects, that is not where it shines the best in that way. And now we are at the end of this trail map, but I did want to have a few other projects as well, so I decided to extend the trail map. And now originally I wanted to make like a really cool using the Photoshop's new like generative function, you know, the AI that would fill me in beautifully there. But for some reason, my Photoshop refused to update to get to those features. So unfortunately, you're stuck with my beautiful drawing, but maybe it's even better this way, who knows. But yeah, then we can start seeing what are the projects that are coming up here. So we have a few projects there to go through. So we're gonna start moving there. We're gonna go to KADA first, which is is relatively new. It was quite unknown still a few years ago, but nowadays when I ask about it, people usually know it quite a lot. So let's see who here is familiar with KADA. Few hands, but not everyone. That's good. But it graduated, I think, literally last week or so. Literally a few days ago. I might be losing touch of like which week is this week or what day is what, but you know, last week or so, or 1 week and a half ago. So KADA is Kubernetes event-driven autoscaling, and it is application autoscaling made simple. So it really goes into this how default Kubernetes scaling is not well suited for event-driven applications, and Kubernetes is more for resource-based scaling, so CPU and memory. But then KADA is event-driven scale controlling that can run inside any Kubernetes cluster, so that you can monitor the rate of the events to preemptively act before CPU is then affected at all. You can install it into extensible and pluggable scalers to grab metrics from multiple sources, and there's actually quite a good variety of scalers for sure. Nowadays, recently as well, in the last KubeCon Europe, KADA also, or like KADA maintainers contributions released also an environmental scaler as well, so that scales on the principles of, you know, making your software more green and sustainable, which is, I think, really cool nowadays as well. And for this one, I have a demo. So I have KADA scaling .NET Core Worker with Azure Service Bus. And I'm supposed to have a few more demos as well, but my demo, Gremlins, demo goblins were not my friend yesterday. Everything started breaking down, but this demo should be working nicely and well. So let's go here actually. Now we are there. And then we need my commands here. So, and you saw the demo architecture there with the order processors and whatnot. And you can think about this demo as, you know, essentially a web shop, for example, that gets a lot of rush orders at one go. So obviously then you need to auto scale up and auto scale down to save on costs or to save the environment or whatnot as well. So that is why auto scaling is very important. And now I need to step one step here. Before we get to the fun part in the demo, we're gonna go see a few different details here so that we get more visibility. And then we go here, we see here order queue length, we see the order queue there, it is all looking good. And then we go here and we grab this one, we do kubectl get deployments here. So there we will start seeing how many order processors are ready and working. And then we go to the last one and we do kubectl get bots here. So in here we're going to see the status of all of those order processors. And now we are nearing the fun part. We do .NET run here. And it's soon going to ask me, let's queue some orders. How many do you want? And can I get a number between 100 and 150? What was it? 140? 140? Okay, okay. The audience reached even like agreement with the number, so that's cool. 140, and then I lost my shoe for a while. That's fine. 140, perfect. Okay. That was dramatic, but oh, there we go. Extra excitement here. But you see all of them coming in. So we have towel, table, shoe, ball, skirt, computer, hair, so many things happening. And now we see the order queue, it's already pumping up quite high. And then we see the order processors getting more and more ready. We're at 1 out of 4, and we can see that it's pending, container creating, as well as kind of getting started on all of these. Creating the order processors and everything so that it can auto scale to meet the demand. And we saw that it peaked at that 140 mark there, and it is going down now because we have successfully kicked off 8 out of 8 already here, and we are now more in the running phase there, and no longer creating new ones, because as you can see we're handling the order queue really well. And we are though scaling up to 10 out of 10. That is usually where it ends up with, around this number. So we are then going down and going down a bit because we are really meeting the demand there. And as you can see, no new orders are coming in anymore as well. So we're doing really good on that one. And now we are at a 10 out of 10 and everything is just running, but the queue has already been handled. So everything is done. Especially fun with the, extra black screen there, causing a mini heart attack, but luckily it got solved very well. But yeah, that was that demo. There we go. And oh, it's gonna start auto scaling down as well, obviously eventually, but it's gonna take a few minutes to do it. So instead of just standing here and looking at that screen, we're gonna obviously move on with the presentation and cover some more topics here. Okay, that was the KADA demo there. Then jumping back into our amazing self-built trail map now. We're gonna move on to KADA, which I honestly think that no one's probably heard about it, and if you have, that's really cool. So KADA, who has heard about KADA? No one, because it's a very new sandbox project, and my company actually contributes to it quite a lot, so this is why I also like talking about it. And it's relatively simple and really straightforward. So it's the Kubernetes backup operator. It is a sandbox project, so very early on, I think we got it to CNCF half a year ago or so, so it's very new in the CNCF ecosystem as well. If you're familiar with Velero, for example, it has a lot of the same feature sets as there. So it has a lot of good things, such as simplified backup process, so simplifies the backup process by automating the backup of persistent volume claims, as well as application-aware backups. So it supports application-aware backups, which means that you can capture not only the data but also the output of any tool capable of writing std out, and it is particularly useful when preserving application-specific configurations or states as well. And you can do scheduled backups and pruning as well, at regular intervals, and automatically prune old backups as well. And then moving on to the next one, which is CubeFlow, which is very trendy nowadays. How many here has heard about CubeFlow? A few hands. Yes, because AI is very hot, and machine learning as well. So CubeFlow is the machine learning toolkit for Kubernetes, and I do like the way that they themselves say the machine learning, because it is kind of the de facto that you use for these things sometimes. So it's designed to make it easier to deploy, manage, and scale machine learning workloads, because they are obviously a bit different in the way that they work than maybe other workloads as well. So it's good to have a specific setup there. So it provides a set of tools, frameworks, and best practices to streamline the development and deployment of machine learning models in the Kubernetes environment. So it provides end-to-end ML workflow. So it offers a unified platform that covers the entire machine learning workflow, from data processing and model training to deployment, as well as monitoring. So the cohesive ecosystem reduces the complexity of managing different tools and components really well. It has scalability and resource management, so you can leverage Kubernetes orchestration capabilities, and it enables easy scaling of machine learning workloads. And you can dynamically allocate resources based on demand, optimizing hardware utilization and improving performance there as well. It has good reproducibility, the hardest word to say pretty much, and collaboration as well. So it encourages best practices for reproducibility by capturing metadata, environment details, and code versions associated with each experiment as well. Yeah, and particularly when to use CubeFlow, well, when you're doing machine learning deployment, for example, and particularly if you're doing machine learning deployment in the context of Kubernetes and with Kubernetes, that's exactly where CubeFlow will definitely shine. And if you aren't doing these things, then I don't recommend obviously using it. Then moving on to the last two projects, which is like a 2-for-1 sale essentially. There we're gonna move this guide there where we have K9s and Lens here as well. So if you're looking at kind of productivity tooling for your Kubernetes setup, these are two really good ones to look into. So K9s is a command line enterprise CLI tool, then designed to provide an interactive, efficient way to manage your Kubernetes clusters. It has, when would you like to use it? For example, if you like to use a terminal-centric workflow, you like really quick troubleshooting tooling, as well as remote management. So that's exactly where K9s is really good. But if you prefer a graphical interface, for example, then Lens likely would be a better fit for you. So it's a open source Kubernetes IDE, so that you can use a graphical interface there, because you can do visual cluster management, you can do multi-cluster management really well, as well as real-time metrics and insight as well. And it's actually really fun seeing if people sometimes do demos, for example, using K9s. It looks so cool that people usually in a live stream might ask more questions about the actual K9s rather than the tooling or the demo that they're doing, because it does look kind of extra cool maybe that you're using it if you haven't seen it before. So now we are at the end of our road, and we can do the final move and continue there. So this is essentially like, you have to obviously then carve your own path. You have to figure out what are the add-ons and the projects that you want to use in the future going further. And there's a lot of good tooling in today's session, since this was more of a more graduated project, more beginner-friendly content. There's a lot of things that you can dive deeper into yourself as well. I do another session that has more sandbox projects that I'm going to do in the future as well, so you can stay tuned there as well. But as a wrap-up, we went through a lot of projects in a relatively short amount of time. We went through all of these. I don't even want to say them all, because I think I would run out of breath if I said these all in one sentence. But then the promised learn more resources as well. So we have a lot of good resources that you can say. All the links and slides will be available at my GitHub. I added a version already yesterday, but then I realized that I had forgotten some stuff, so I will do an updated version later today. You can always check out the CNCF landscape. There's a gazillion things for dueling there, and if you want to kind of see the latest and greatest, then I recommend going to the sandbox project area there, and then trail maps you can check out there as well. And now the link here, but if you want to find this and you don't remember the link, you can just put Kubernetes in 2023. That's it. That's the name that you can find it from YouTube. It was Brendan Burns and the maintainer of Flux, talking through 1 hour of, okay, if you are thinking about doing Kubernetes in 2023, what are the considerations that you need to consider? So that was a really good one, particularly I think from the perspective of Brendan Burns, one of the founders of Kubernetes, talking in the context of now, what are some of the decisions and considerations that you should make. So then you can kind of check that out and then make some decisions on which projects that you want to use it. But I did give a condensed version of it in the beginning as well. But that's it for today mostly. I do want to leave you this so that we can all be happy that we are using Kubernetes, and we can just enjoy simply that fact that we have managed to do something so complex. Thank you, everyone. And if you have any questions, I'll be here, so you can come by here.